Imagine just typing out a sentence and then watching a fully realistic 3D character spring to life right in front of you. Well, with HighMotion 1.0, that's not science fiction anymore. This is a breakthrough AI model that is totally changing the game for 3D animation, turning simple text commands into some seriously dynamic and complex human motion.
So, just how powerful is this thing? Well, take a look at this command. Run forward and play football backward. You'd think that might confuse an AI, right? But nope. The model completely understands the sequence and generates an animation that does both actions, one after the other. It shows this incredible grasp of logic. But where it really shines is in the small details, the nuance. The prompt here is super simple. A person walks unsteadily. The result, though, is anything but generic. You can see the subtle stumbles, the little balance corrections, all those tiny details that make a movement feel genuinely human.
And we're not just talking about simple actions either. You can give it something highly specific, like Tai Chi, and what you get back are the fluid, graceful, and really precise movements of the actual martial art. It just goes to show the massive range this thing has, from everyday gestures to super specialized, complex disciplines.
The results are obviously impressive, but the technology that makes it all possible is honestly even more so. So let's pull back the curtain a little bit and look at the AI that's actually powering all these moves. The engine driving HighMotion is something called a billion-scale diffusion transformer. Now that term, billion scale, is really the key here. It's talking about a massive, incredibly sophisticated architecture that can process and understand motion on a level that was, frankly, impossible before. So the magic really happens in what's called the diffusion process. The best way to think about it is like a sculptor who starts with a raw block of marble. The model begins with just random, chaotic motion, basically pure noise. Then, guided by your text prompt, it methodically starts to chisel away at that randomness, step by step, until a clear, realistic animation just emerges. The entire workflow is a pretty cleaned three-step pipeline. First up, at the input stage, the model looks at the text and predicts how long the animation needs to be. Second, in processing, that diffusion transformer core gets to work refining the motion. And finally, the output, a ready-to-use skeleton-based 3D animation. You know, a model this smart doesn't just appear out of nowhere. Its incredible performance is the result of a really rigorous, multi-stage training regimen that builds up its expertise from the ground up. And the foundation of its knowledge is just immense. The model was initially pre-trained on over 3,000 hours of motion data. That gives it a vast, general understanding of pretty much how humans move across countless different situations. But that huge pre-training session is just step one. In step two, it gets fine-tuned on a smaller, specially curated set of high-quality motion data to really sharpen its skills. And then, this is crucial, in step three, it learns from actual human feedback, which helps align its final animations with what we think looks natural and correct. It's that combination that really pushes it to state-of-the-art performance. So we've seen what it can do and how it works. But the real impact, the reason this is such a big deal, is how it's going to completely transform creative workflows, basically squishing tasks that used to take hours into just a few seconds. And the applications are immediate and honestly profound. For game developers, you're talking about generating procedural animations on the fly. In film and visual effects, you can rapidly prototype character movements without booking a whole MoCap stage. And for virtual production, this can be integrated directly into existing pipelines. It's a game changer. And here's what's absolutely crucial for any professionals watching. The model doesn't just spit out a video, it outputs industry-standard FBX files. This means its skeleton-based animations can be dropped right into game engines like Unreal and Unity, or software like Maya and Blender. It fits seamlessly into the workflows people are already using. Of course, no technology is perfect, so for a balanced view, it's really important to understand not just its amazing capabilities, but also where its current limits are. So the model's strengths and weaknesses are pretty clear. It absolutely excels at complex, nuanced motion for a single human character. But right now, it's a bit limited when it comes to multi-person interactions and non-human characters. So for now, you can think of it as a specialist, but a remarkably capable one at that. The key takeaway here is pretty clear. We're right at the beginning of a major shift in how digital content gets made. By putting the power to generate complex human motion into anyone's hands, this technology isn't just a new tool, it's a brand new canvas. It's empowering creators to tell stories and build worlds that, until now, were just too difficult or expensive for many to even attempt.